Intro. It's a report that has become almost routine in the world of astronomy. The James Webb Telescope has once again identified a mysterious structure that shouldn't actually exist in this form and which once again calls our current models of early galaxy formation into question. How can a galaxy have been 10 times more massive than our Milky Way today when the universe was still in its infancy? Today we'll show you the exciting discoveries Webb has made recently and what they mean for our overall understanding of the cosmos. At the same time, we'll take a look at the latest images from the James Webb Telescope and explain what the overwhelming structures romping around in the gigantic vastness of space are really all about. Not all galaxies are barred spiral galaxies. The same experts distinguish between three basic types, namely elliptical, irregular, and spiral galaxies. Our Milky Way belongs to the latter type but is more specifically classified as a barred spiral galaxy, and there is a very simple reason for this. The spiral arms of our galactic home are attached to a straight structure that runs through its center. However, this bar not only shapes the appearance of the Milky Way but also acts as an essential supply route for gases, and thus for the material that fuels the birth of new stars. However, a barred spiral galaxy needs time to mature and develop its characteristic shape, which is why astronomers long assumed that this special type of galaxy had only existed for a few billion years. Well, you can be mistaken. In fact, the James Webb Telescope showed a good 2 years ago that barred spiral galaxies were already an integral part of the cosmic landscape 10 to 11 billion years ago. Shortly thereafter, researchers even found an even older Milky Way twin, Sears 2112, which may have formed only about 2.6 billion years after the Big Bang. But now the list of early barred spiral galaxies has been expanded with another remarkable entry, one that can confidently be called a galactic colossus. At 11.1 billion years old, the structure christened J0107a is not the oldest known barred spiral galaxy, but it is all the more astonishing for its incredible dimensions and dynamics. The bottom line is that we're dealing with an object that has a star formation rate 300 times higher than our Milky Way and is also 10 times more massive. Discovered by a team led by Shuo Huang from the National Astronomical Observatory of Japan, the new discovery is also the most massive known barred galaxy from this period, even surpassing the most massive galaxies in the local universe. However, it's not only its size and mass that is puzzling scientists, but above all its advanced stage of development. Huang and his colleagues comment, J0107a is the most distant and massive galaxy with a fully developed bar. The discovery, why the galaxy is shaking up our theories. We owe this new insight to images from the James Webb Telescope and data from ALMA in Chile. In detail, the ALMA data made it possible to reveal the movement and distribution of gases in the galaxy and thus show experts that the bar is transporting immense amounts of gas from the surrounding areas toward the center. In figures, this means that gas is flowing in at a rate of around 579 solar masses per year, significantly exceeding the average 0.01 to 50 solar masses of the local barred spiral galaxies. The researchers conclude that the bars of early galaxies were apparently able to behave more actively and wildly than their present-day counterparts. This wild behavior also explains why star formation within the discovered structure is so exceptionally high, at around 500 solar masses per year. At the same time, however, the enormous gas supply could also be responsible for the increased activity of the supermassive black hole at the center of the galaxy. This naturally raises the question of how this is even possible, and the current answer is that we simply don't know yet. After all, the early barred spiral galaxy turns our expectations upside down in several ways. First and foremost, of course, are its enormous mass and fully developed bar, which dispel the notion of the leisurely formation of this type of galaxy. In addition, the composition of the bar also leaves experts scratching their heads. It consists of 70% gas and only 30% stars. Ultimately, we are once again dealing with an astronomical impossibility. As astrophysicist Dayan Fisher from Swinburne University of Technology explains, according to current models, the gas-rich environment of galaxies in the early cosmos prevented bar formation. But the latest observations now reveal an early bar galaxy and gas dynamics that were not thought possible at that time. The findings thus directly contradict this theory. And although the puzzling discovery raises more questions than it answers, it has already provided us with a fundamental insight. It shows us once again how little we really know about galaxy evolution and other processes in the early cosmos, and that our models only hold true until they are overturned by a contrary finding. Outgrowths, the overwhelming beauty of the universe. Beyond the confusing structures that Webb is now revealing with some regularity, we should not forget that its sharp infrared vision is also suitable for a completely different purpose, to show us the incredible splendor of the universe in a way never seen before. In recent weeks and months, Webb has captured a whole series of wondrous cosmic outgrowths that simply leave us speechless. It starts with Webb's image of the planetary nebula NGC 1514, released just in time for Easter. This colorful object initially looks like two cosmic eggs in an Easter basket. But what is it really? Well, contrary to their name, planetary nebulae have nothing to do with planets. The name simply comes from the fact that the objects looked like the planet Uranus when viewed through 18th-century telescopes. In reality, however, we're dealing with a colorful stellar remnant, when a star swells into a red giant, ejects its outer layers into space, and eventually collapses into a white dwarf. Its radiation causes the surrounding gases to glow. The planetary nebula photographed by Webb is located about 1,500 light-years away from us in the constellation Taurus, and thanks to the mid-infrared instrument, MIRI, it can now be seen for the first time not just as a blurry spot, but in all its fascinating facets. At the center of NGC 1514, two stars slumber, but they appear as one in the image. One of the two celestial bodies was once more massive than our Sun, and it probably played a decisive role in the formation of the structure. However, we're essentially dealing with a very short-lived structure. While the nebula took at least 4,000 years to form, it will disappear again in a few thousand years. And what seems like an unimaginably long time to us is, in an astronomical context, nothing more than a fleeting moment. The situation is very similar in the case of Herbig-Haro 49/50. Unlike planetary nebulae, however, Herbig-Haro objects do not mark the end of stellar life but accompany its youth. In order to grow, young stars must absorb large amounts of matter, but at the same time, parts of it are ejected in the form of straight jets. These Herbig-Haro objects can then extend light-years into space, and as soon as the outflows encounter a zone of denser material, shock waves are created that heat up dust and gases to extremely high temperatures. After cooling down, they look like colossal space tornadoes. The corresponding Webb image consists of several images in the near and mid-infrared and shows a structure about 630 light-years away in the constellation Chameleon. The originator of this remarkable spectacle is believed to be a very young star that is only a few tens of thousands to a million years old, and is therefore at the stage where it can best gain mass. However, there are still some remarkable objects hidden in the details. At the tip of the orange-red tornado is a bright blue spiral galaxy, which appeared only as a blurred spot in earlier images and could not be identified more precisely. What could be identified more closely, however, is the object Lindner 83, which shows nothing less than the turbulent interaction of two young stars. Located 650 light-years away in the constellation Serpens, the stellar youngsters have been hurling matter into space in the form of two cone-shaped gas jets for tens of thousands of years, creating a cosmic work of art reminiscent of glowing twin flames. Webb's near-infrared camera has captured the scene in unprecedented detail, allowing us to marvel at the striking orange arc extending to the upper left. More precisely, this component is caused by a shock front, where the stellar ejecta is slowed down by denser material. The bright purple column-like structures in the right half of the image are evidence of the relentless winds of the young stars and were formed because their material is so dense that it has not yet been blown away. These young stars lie dormant in the center of the object, with the flames extending out on both sides. However, they are still hidden behind an impenetrable disc-shaped veil of dust that is no larger than a pixel in the image. At the same time, the image also gives us a glimpse into the cosmic future. In millions of years, the stars will have approximately the mass of our Sun and will then only be surrounded by a rotating disk of gas and dust. Within this disk, and this is the exciting part, planets may then flourish, and perhaps even life. And now you can even subscribe to our channel on your YouTube homepage. Just click the thumbs up and then subscribe to never miss another video from us again. We'll see you soon.